Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust and try to learn Rust in between. I'm Eugene.
Luciano.
Roberto.
Thank you everyone for following along, and thank you for joining. Now, if you never did Advent of Code, this is basically a code challenge that's published every year around the Christmas period in December. There's one coding challenge released every day up to the 24th of December. So there's 24 challenges overall. You can find them on adventofcode.com. We're doing last year's Advent of Code right now. We're publishing our codes on GitHub. Luciano, if you could put a banner, thank you very much. Perfect, thank you. Feel free to check out the code there and feel free to submit pull requests if you have ideas or any potential improvements. Now, we left off last time doing exercise 17, if I'm correct. I hope I'm correct. We were working on part 1 of that. So let me pull before I share my screen. Doesn't that sound like a good idea? Oh no. I don't have it here.
Meanwhile, I'm gonna mention this comment here, which is really cool. Selective duplicate. Hello. Yeah, Advent of Code is a little bit of madness, but I think to learn Rust, you have a bunch of interesting exercises. Like you can try a bunch of interesting things. So if you want to do that, we are curious to know how it goes for you.
Even if you force yourself to avoid to clone everything, because we started cloning everything.
Yeah, they are fun exercises. So, handily, we have left to-dos for ourselves, but essentially, maybe it's better to start zoom in, of course. It might be good to start with the README. Can you see it, or is it too big now?
No, it's
Good.
fine.
It's just good. All right, cool. So essentially, this is a game of life simulation, game of life type of challenge. We're given an initial grid. It's for a 3-dimensional game of life, the first part of this problem. So we're given a grid where we have either active or inactive cells. We're supposed to simulate 6 cycles of cells, and on every cycle, each of the points on the grid will change between active and inactive based on some rules which are defined here. If a cube is active and exactly 2 or 3 of its neighbors are also active, it remains active. Otherwise, it switches to inactive. If the starting state is inactive, but it has 3 active neighbors, the current point will also become active. So we have to simulate 6 cycles. There's some examples here, so I won't go through them because we've done them last time. But I will go a bit through the code that we have. So the first thing we're doing is we're actually parsing the initial cube, the one that we start with. We've defined a type for the cube, which is basically a hash set of points, and a point contains an x, y, and z.
Can you show maybe very quickly the input file, just as a visual reference?
Hang on, I do have it here. Yeah, this is our starting point. So it's an 8x8 grid. We have some active cells and some inactive cells, or points as we call them. We're parsing this into a cube. So we have x, y, and z or z for each one of these points. We're starting with z at 0.
Mm-hmm. Yeah, I suppose that's interesting to clarify that initially, so this is kind of a 3D space.
Yeah.
And but the initial view is like a plane, and then this plane can grow in both directions of the z-axis. Yeah, so that's why we have like a 2D input, but then we kind of parse it as if it was a 3D space, which is flat on the z-axis as a starting point.
Yep, it's a flat slice of a 3D space, if that makes sense.
Mm-hmm.
So yeah, we're parsing this into our cube, which is at this point not a cube at all, and I don't think it will ever be a cube because it's probably not going to grow to become equidistant, but same size.
Distributed, yeah.
Yeah, distributed, exactly, fair distribution. So we're parsing this into a cube, and we also wrote a function which gets us the neighbors of a point.
Can I mention something very quickly on that cube?
Yes.
So one idea that I think Roberto suggested the last time is not to create like a full 3D space where you have a specific set of dimensions and then you fill all the possible points in memory, but instead doing like a sparse matrix, which is something we are doing with an hash set. So basically we are only storing the points in this space that we know are going to be live. So when we pass the input, we basically ignore every single point that is not live, and we only store the ones that are live. I suppose the idea there is that this space can get really big, but most of it is going to be empty. So it makes sense to go with this approach. And the second idea is that you are going to change the space between cycles, but only the neighbors essentially will affect creating or destroying points. So just keeping around the live points will be enough for us to understand how to cycle to the next step, let's say. So this is at least the theory why we are structuring the data this way. We'll see if it actually works.
Also, the README say that the space is unlimited in every direction, so we can know before how big is our space.
Yeah, this starts.
Even if you want to do that with an array, but we know that this initial one is 8 by 8 by 1, but the final one can be, but we don't know.
After 6 cycles, well, we only get 6 cycles, which is good because it's bound, because usually the game of life goes on forever.
Yeah.
And
but
poses
still, you
memory
can't
issues.
In which direction it's going.
No, of course. Well, presumably it can't grow too much, I guess, in just 6 cycles.
It can't go too far away, but
one thing
is complexity that we don't want to handle.
Exactly. One thing we should mention is because we didn't mention this when we were going over the rules, and it took us a little bit of time last time to figure it out. We start with a thin slice, as in a depth of 1 on our cube, but we add more if we get active cells. If there are no active points on the neighboring slices, if that makes sense, we don't add a new one. So it stays the same size it was before. Also, another interesting effect that we noticed is, since we're starting with a slice of 1 depth, basically, the cube or the shape is going to grow equally both sides.
Yes,
so this may be something symmetrically. This may be something we can take advantage of to make this more efficient.
But like we always do, let's make a working solution, then we can optimize.
Exactly. Right. So we're generating the neighbors of a point here. As in, we're generating the coordinates for neighbors of a point. And we've also made a next state function for the cube method, I should say, because it's part of the cube, which will generate a new state. It currently just returns the previous state, and we finally left some to-dos for what we need to do. One thing which is important to note here is every state needs to basically be a completely brand new state, because it's based entirely on its old state. So all the changes have to happen simultaneously. So I suppose we should start by literally going over each point in the cube and store the neighbors for now, and then apply the rules to each of the points, right?
That makes sense, yeah.
All right, so here we're going through, we're making an iterator out of this point in old cube, I suppose. Sorry, somebody's written Python today. Apologies. I do what I can. All right, so we have a point. We need to get the neighbors. If I can type. point. And how do we want to apply the rules?
We can do that here. Let me think. Oh yes, we can do that here.
We can do this in scope.
I think the first thing we should do is count the active neighbors, right?
Okay, so here we are in the phase of taking every point in the cube, take all the neighbor of all the point in the cube, and counting the neighbor of the neighbors to see if this and apply the rules. What I'm thinking is that when you have two points, you have a set of neighbor, then you have another set of neighbor. Those two sets are okay. Thank you. Those two sets overlap slightly because points are near everybody. All the points are near the next points. So if we go on top of the loop and we check the neighbors of the neighbors every time, we go exponentially high. So it would be super, super slow. We already know. So what we can do is creating a set of points, again, that are all the points that we have to check.
Okay.
All the points that we have to check are all the points that we already have in the cube, plus all the neighbors of all the points that we have in the cube. Those are all the points that we have to check.
Okay.
So in line 25 or between more or less there.
Yeah.
Before the loop, basically, we can create a hash set of points empty that will be all the points to check.
Okay. So okay. So you wanted to do all of them in one go. Okay.
Yeah, because a lot of them will overlap. So instead of counting for the same point, the next state, I don't know, if you have free cell, you have the neighbor that is neighbor of all the free cell. So for every cell, you will take this point and check his neighbors. But it's enough to check once. You don't have to check 3 times because his neighbor are not going to change.
So a hash set of points, essentially.
Yes, with angular
brackets.
Apologies. Hash set new, I guess. Okay, and can we iterate, I guess, over these, right?
There is a way in Rust to extend a set, update a set. I don't know how to.
Let's see.
To throw not a number in the, not an item in the set, but a collection of items in the set.
I can search for that.
Let's look it up.
We can do with a 4 like Eugen was doing, but yeah, probably there is something.
Yeah, meanwhile I can search for that. Of course, if anyone watching knows that, feel free to suggest. Unless you want to see us suffer.
So let's see.
Eugen implemented the 4.1 in the meantime, so we just have something working. Then if Luciano finds a magic function method that can do the job
value. For us. So there is an insert on a hash set, but it only adds one value.
Yeah. Is there something insert multiple values? I don't know how to call it.
So there is union, which allows you to join 2 different hash sets.
But our input is an array. It's not the neighbors are an array. They are not.
Yeah, we control this, so we can make this.
We can make them a hash set, but I don't know if it is more memory efficient to have a hash, because we know that they are 26. There is no way of it.
Yeah, that's true.
A different. But let's go with the 4, Eugen.
Yeah, let's keep it simple for now. Then if we find
right? Oh no, I turned off. I forgot. I turned off the. Jeez. There was one of these.
You turned it off everything.
Everything. It was getting in the way of what I was doing here. Interfaces and functions, I think. Right? No. Crap, sorry. Fine, just take everything else on, I guess. Damn it. Show. Come on. there anything I missed? Yes. If anybody knows which one suggests you methods from things, do put it in the chat, because I am not very good with VS Code. Jesus. Come on.
You're fighting with VS Code?
Constantly. It's only because I don't know it. What's this TypeScript? No, wait. We don't have TypeScript yet.
But well, I hope it's not suggesting you TypeScript stuff inside the Rust code
Hopefully
base.
not. Suggest. Okay, this should be everything. Apologies for wasting everyone's time by not setting up my thing. Okay.
Okay.
For no, fine. Sorry.
So I think we have a suggestion here.
Oh, that would be lovely.
Chain set.
What is that?
Ah, interesting. Let's see what is chain.
What is that kind of stuff?
So basically, we can get this guy, points to check, into iter chain. What does chain do? It was
I think it takes another iterator, right?
And our
yes.
function is returning an array that is iterable.
Technically, let's see what it
Arrays are iterable, yeah.
So, yeah.
100%.
Do we have to do to iter or?
You probably need to do either. I'm not sure about that.
Oh no, it was actually into iter, right? Seems no. Why is it unhappy? Type mismatch.
You are collecting, but you're not assigning to anything.
Yeah, you're right. You're
I don't know if we have to assign. Chaining is working in place or creating a new.
Let's see. No,
because
it's
we
still
have to
unhappy
take
with
this
this.
set
I
and
think
go on
if
adding stuff to it.
it might create a chained iterator. Let's see.
So takes two iterators and creates a new iterator over both in sequence.
Yeah, so pretty much it's going to give you all the initial elements, I guess, of the initial points to check, and then it's going to give you the elements of neighbors of points. So I don't think this is exactly what we want to do.
No, probably not. So let's go back to more simply insert for point in insert.
By the way, we also have this question, so let's try to explain again what's the current idea. I'm going to try to do that, Roberto. Let me know if it's correct.
Yeah.
But basically, the idea is that this is a game of life. So essentially, we have a space. In this case, it's a 3D space, but you have points. And then for every single point in the grid, you have to decide at every cycle which cells are alive and which cells are not alive. And there are rules based on neighbors. So if you have a certain number of neighbors that are alive, then you live, otherwise you die. I am simplifying it, but this is the idea. So what we are doing here is essentially we have the initial list, which is only the live points. And that's basically our...
Sorry, we're doing this here just... so we're taking the input, which is this thing. Mm-hmm. Every hash is an active or a live cell. And for every one of those, we're setting it as our initial list of things, which is what we're getting here. And then we want to get the neighbors of all of these things to see which one is active, so we can apply some rules to check how they would change onto the next iteration.
If you go in the input, for example, in line 7, at the beginning of line 7, there is a dot. Line 7, there is a dot. That dot will not be in the points to check. Why? Because it's not neighbor of any active cell and is not an active cell. So it's useless to check if that point in that coordinates is useless to check it, because it's impossible that that point change state, because there is nothing neighbor to it to change its state. And we know it because we know the list of the active cells. Mm-hmm. So,
and also for every active cells, we can easily get all the neighbor points in space.
Yeah, exactly. So it's useless to waste the time to check that specific point. Think of this in a 3D space. Okay, in a 2D space, when you do a 2D game of life, you can invest some time even in cells that are obviously not going to get alive. In a 3D space, the numbers are rising because 3D. So not taking in account cell that will never change is better.
Now,
And we are putting everything in a set because a cell is neighbor of multiple active cells. So we don't want to compute the same cell 6 times. So now point to check dot insert p.
Yeah. I was gonna say, sorry. Let me just do this. Was it insert? Yes, insert p. That's done. Now, we said we also wanted to check the points.
What is p? I probably have to do iter because p is a very strange type.
No, yeah, you're right. This is correct.
Okay, now is a reference. Is a reference. Oh my god, let's start with reference.
It's fine. No?
Declarable mutable. You declared it mutable.
Try to use iter rather than into iter.
Sorry. This method might not be. Why is it scrolling? Sorry. Because I'm not particularly smart. Just iter, you're saying.
Mm-hmm.
Yeah, okay, cool. Yeah, because into iter transforms.
Same in the one above. I think if you just use iter.
Yep.
I don't think it makes a difference for now, but otherwise, is it?
Because
and found
or
reference.
we accept a reference up there in the neighbor point, or we accept a reference.
We could, because we're not consuming it, right? Oh, whoops, sorry. If you put the reference in the right point, the right place, it might even work. Yeah. But this doesn't need to consume
because
it.
then you use it in the same exact way.
Yeah, exactly. Okay, so we're getting
in the line between line 26 and 27, we also add the current point to the point to check, because we have to check the current point if he's dying for reasons.
Oh.
Point. Okay, types are fine.
And this probably needs to be,
At this point, points to check can be a nice set of reference to points if we want to go down in that rabbit hole.
We don't need to keep it in here, so it's fine.
Okay. But those are integers, so in theory, copy trait is working for that.
That's true. It doesn't matter. Okay, so
now
we're doing
the
this
points
thing
that we have to check and apply rules to. Cool.
Yep.
So we can cycle on top of them.
Yep. Yeah, I'm thinking, okay. Do we just do another? Yeah, let's just do another simple, boring loop. Apologies for everyone who's probably.
Yeah, we can try to refactor it later and make it.
When we have green test, we do everything.
Yeah, the way we approach this, just to say it, is we do not the best code the first time around. We just write it so it works, and then we work on it and improve it and so on at a later point. We've also gotten some pull requests with improvements over time to our repo, some of which are actually merged in and so on. So feel free to contribute as well. For anything you see here which you think is terrible, if you have any ideas, once this thing is out, you can create a PR and we can discuss it next time.
In the closed PR, because there are good ways of refactor code, from ugly nested loops, for example, into chaining of map, filter map, and
what happens if I say for point again?
I think we didn't destroy it. Well, we didn't consume it, so it should be fine.
Well, point is the
unused variable. No, yeah, this was generated
point,
here.
I think, is only alive inside that for loop.
Inside the for. Okay.
So you can do another for loop.
I never knew
this. The scope is the for loop for the variable.
Correct.
Name.
Okay, so now we need to actually check it.
Now we have to count the neighbors of this point, and we can create a function to count the neighbors. Or we can do it here, what you prefer.
We already have this stuff, I suppose.
We have already the function to get the coordinates of the
but
neighbor,
wait.
but we don't know if the neighbor is alive or not. We have to check if the neighbor is inside the board.
Wait a second. So these are points to check, which are basically all the neighbors
Of the
and
cell
our
alive.
points.
And the alive cell too, yeah. Now, for these points that we have to check, we have to take all the neighbors of those points and count the alive neighbors. A neighbor is alive when it is inside all the cube.
But we don't want all of their neighbors. We just want the neighbors that are in here, basically. Because you don't want to... Essentially, what we've taken now is we've given coordinates for this. Everything surrounding, including our data. And we don't want the neighbors of these.
We need to see how many neighbors do they have, because they can have 3 neighbors and they can become alive.
These things.
Yeah, that thing, if you count the neighbors of that thing, not that specific one, but go where we can have something. Like, for example, line 4. If you go one cell left of line 4, left.
This one.
No,
yeah.
Left, that is right.
This one.
No, left. Go to the first character.
Okay.
Yeah. We are taking a cell left to that now is not there. Okay.
Yeah, that one will become alive.
That one cell will become alive because it has 3 neighbors, but we have to count them, otherwise we don't know.
We do, but we need to count what we have
the
in
neighbors
here,
of
basically.
that cell. Yeah.
Let me
make sure to check out this file, because this is our
actually there's an easier. It's not showing me that it's changed. Oh, because it didn't save. Thank you.
If you Control Z enough, okay.
Done.
One thing I can suggest is maybe we can do another helper function, because at this point we don't care anymore about the neighbors. We just care about how many of them are alive, right?
Yeah. And the helper function needs the board and the point.
Yeah, or count alive neighbors, something like that.
Active, because and this is going to return
number.
U sides, I guess.
U sides.
Yeah, is between 0 and 26.
So. And it needs to get a point.
Point and the board.
Yep.
Make it maybe a reference in both cases.
Both should be references, you're right.
We are not changing them, we are just respecting.
Can we rename cube to be board, maybe? Because we've already started mixing.
But a board is just should be space.
Cool.
Guys. Naming is hard.
No, it's just to keep them named the same, because I'm gonna start asking, so what's a cube now? What's a board? Or not now, but I'll ask this next time.
Probably now there is some fancy way of doing that with some chaining of stuff, but the C++ developer in me, that's me, to initialize a counter to 0 and increment it.
I think we can easily do a filter and then just do a count.
But we don't want to filter the whole thing, though, right? Oh, we want to just filter the active ones.
No, so you call the neighbors. You get the neighbors for that point. Then you iter over them, filter the ones that are active, and then count. Okay. And that should give you a U size.
So neighbors of point, filter.
Iter filter.
Filter.
Sorry.
And then here we need to check
we have to take only the one that are in cube.
Yep.
So cube.contains.
I think contains, yes.
P.
Len. Count len. How do you get the length of this?
No, dot count.
Dot count. It's a function, or it is okay? It's a function.
I think it's a function in the iterator chain.
Okay, so basically we are taking the points, the neighbor of the point.
So...
If they are in the cube, we count them.
active Jeez, I hate writing this word. Count active neighbors of
point, and
which should be referenced point.
cube. Yeah, reference to the point.
Where's the function? It's a reference, okay. Just making sure.
And the
Okay.
reference to the cube. Okay.
So
now the rules.
Wait a second. Cube here is not our cube, but it's old cube.
Sorry, old cube.
You're correct.
Because cube is the one we are building for the next iteration.
Is the destination, sorry.
Okay.
Now, rules. If the cell is alive, what are the rules? Copy and paste the rules here as a comment.
Give me a second. If a cube is active and if a cube is inactive, that's what we want here. So if active and 2 or 3
and active neighbors
are active,
well,
cell stays active.
So we have to set the cell in cube.
Let's just write it like this, else cell becomes inactive, just so we don't lose the idea. It's a bit more readable than the big thing, right?
Mm-hmm.
Inactive, and 3 active neighbors are active, becomes active, which is not a cell, it's a point. That's what we call them. Sorry.
Cell point. Yeah.
Oh no, I touched the wrong button. Apologies. Okay, cool. So if point is active, so let's find out if the point is active first, right?
All the cube contains is.
Yep. Old cube contains point and which was double ampersand.
Yep, exactly.
And active neighbors smaller
is 2 or 3. So
actually equals to 2. Or
you might need parentheses.
Yeah, you need round brackets.
I will.
For operator precedence.
Doing this now. Okay, so if these are the cases, I don't think we need this one though.
You don't, yeah.
Okay, point stays active. It's basically do nothing.
So,
cool.
No, wait, we have to set in the cube because cube is empty at the beginning. We have to set in the cube.
Oh yeah, okay, correct. Cube insert.
Yeah. Point.
Do point. Else. Else we do nothing.
Else we do nothing.
Yeah, exactly. I think it's interesting to remark that since we are only keeping around the active points and every frame, every iteration, we start with a new cube, which is empty. Basically, here, what we care about is only inserting the alive points in the new space. And that's it. Like the ones that we don't insert again are the ones that died between iterations.
This is a bit different. So if the old cube contains the point,
does it make sense to do a variable and call it is alive? And so we avoid that double if. Well, that old cube contains all the time.
Yeah, let's see. Okay. Point is alive. And this is an optional.
Remove.
Sorry, I didn't say that.
Okay, now it's a boolean.
Reference. Okay, point is alive. Okay, and that's okay. If not point is alive and active neighbors
are exactly 3.
Cube insert point.
So they can go in OR. Those 2 conditions can go in OR, but let's do that later.
Yep, they can both. Yeah.
Why is complaining about the insert? Because cube is not mutable. Line 28.
Fair enough. That is 100% fair enough.
Also, we have a suggestion here that we could do this a little bit more nicely with a match and a tuple, but
okay.
I think it's a good idea. We'll leave it for the end if everything works as a refactoring idea.
Okay, true.
Fair.
Cool.
Check a live neighbor. That's done already.
So that's basically it, right?
So we just return the cube and that's it.
We have to tell the number of calculate the total number of alive points, cube length. So 68 instead of returning the solution.
Yeah. I'll leave this here though. Okay, cube into iter, right?
No, then
and we filter.
I think you might have just
no.
length.
Length?
Isn't it len?
No.
I was thinking we had len. Let's see. Or maybe there is size.
Size, I think.
No, there is len for sure, by the way. I'm seeing it in the documentation. So you just do .len and that's it. Yeah.
On the hash
set. U32. This needs to be U size.
Fair enough. Yeah.
Let's
you can do that for now and then we can change it later.
Exactly. Let's see if it works and we'll make it nice.
Fingers crossed. No disaster.
Expected reference found tuple.
Okay, so this is an actual error in the compiler. It's not.
Yeah. Is it the only one? It is the only one. Okay, line 93.
Oh, 93. What we did? He wants. Writing it. He wants a reference to a tuple, not a tuple.
Okay, give it an ampersand there.
Yeah.
That should do it, right?
If it's everything, I'm very happy.
Yeah. This is the test for
it was just because we changed, of course.
Yeah,
we changed the signature.
We changed the signature and didn't update the test.
Yeah, we should mention that we wrote a test for the neighbor generation last time just to make sure it works. And the test did its job. It showed us that we changed the interface. Absolutely fair.
Okay.
Ooh, very nice. Worked. Worked at the first try. Good job.
Nice. It did run in 6 seconds.
It's very slow. We can address it.
Yeah. Okay. Well, let me remove these because we don't need them anymore. What do we do? What do we fancy?
So we can try to do that match statement, which I think is interesting.
Line 40.
40. For these.
Instead of doing that match that was suggested.
So basically the idea is that you create a tuple which contains point is alive and active neighbors. Okay. And then we can create matching statements for them, basically.
I think you can write them.
So what do we call it?
Write it in line.
Write it in line. Like
line
here?
You can do in line a tuple match and then put active parentheses top in the same line as match.
Sorry, I've not actually
open parentheses and put active. Sorry, point is alive, comma active neighbors.
Mm-hmm.
And then there we can put true and 3 in. I think still you need parentheses.
I will. Up. Jesus. Yes. And this was a colon here? No. How did you
And then
this?
You need to put an equal and like a fat arrow, yeah.
Like so?
Yes, and this is what the match statement is going to return.
Okay.
So cube insert point, for instance. Then I think you need a comma between match statements. Mm-hmm. And now true and 2 and do the same. Or false and 3. Now, I think there might be a way to also... There might be a way
default case now. Why is it unhappy with this?
Because it needs a default that doesn't do anything. So you need an underscore, I think.
No, underscore.
It's just underscore, I think. And then arrow and just do nothing.
Open, close the curly brackets. No, you're missing a comma in line 43.
No,
Yeah.
No, remove the curly brackets. It was the comma in line 43 the problem.
Oh, because insert returns something. Insert returns, so that's why it's saying that.
Do I put these in block?
Yeah, insert returns a boolean if it's actually inserted for the first time, or if it was already there, it will return false.
Okay.
Now what's
So I am thinking another idea.
Yeah.
We can say insert equal, so we can create a boolean variable.
Okay.
So all
Where?
this match statement will return a boolean. So
Okay.
rather than doing insert there, we can do true or false.
So
basically.
like inserted is going to be this match basically.
Let's call it to insert, something like that.
Okay.
And then rather than doing cube insert, you do true everywhere and false in the last one.
Yeah.
Okay, I understand.
That is false.
It might be good to explain. And now I understand the idea.
I don't know if there is a better way to do this, because now we need to do another if statement,
So
like
if
if
to
to
insert,
insert, blah, blah, blah.
Let's see if it works.
It's not happy. Ah, yeah, of course.
You need a semicolon, yeah, because that's an expression.
That's fine. It seems happy. Let's see the test. And let's see if anybody has commented anything on this. No.
It's even faster. 4 seconds faster. Okay.
Jeez.
I think it might take into account the compile time there, and that was...
okay, if he's taking the compile time.
It was the first compile. Let's see. Well, I can always undo, but...
No, but, well, probably... okay, it's
this is even quicker now.
It's fine.
Yeah, it keeps in... So it can vary a lot the first time.
Question on that match statement. Aside the if is horrible, probably there is a way to avoid it, right?
I think you know what you can do? You can do an if on the match, because all of that is an expression. But
yeah,
again,
it
looks a bit ugly, I guess.
Yeah, I'm not sure.
Match, why not?
Try, if match, and then you do that, I guess.
Seems happy. This is actually not bad. It's not usual, as in I haven't seen this in other languages.
No.
But it's expressive. Yeah, it works.
Question that I have on that match, again. Line 41 and 43 are the same. So they are just checking active neighbors. So if
you can do an OR.
Okay.
You can do an OR.
You can do an OR.
No. Go back. After the first parenthesis, you can do OR. Before the arrow, you can do OR and specify the other cases.
Mm-hmm.
What I was asking was different. Can you do open
brackets,
underline comma free close brackets true?
It's not happy with this though.
Maybe just one.
Maybe
one type. No, I think maybe it's just one pipe. Let me check.
You're right.
Much, then, and you can do it also with the other one. Basically. We have only 2 cases.
Okay, true or false, and we're grouping it by returns now rather than by conditions.
Okay. So at this point, you can probably do cube insert straight there in line, and then the other one returns false because we know cube insert returns a boolean.
QB insert needs to return the point.
No, it doesn't.
No, it returns either true or false, depending if it's a new element or if it was already there.
Okay.
So that should work, I think.
No.
Complaining about what?
It needs a semicolon at the end, I think.
Magic.
Okay.
Because the whole match statement is returning.
Yeah, he's returning something, but we don't care and we discard it.
Let's see if it runs. It does run. Beautiful.
Cool.
That's nice. Thanks for the suggestion and thanks for being smart, Luciano and Roberto.
Okay, can I try another stuff again?
Yeah, please.
I don't know if it works. I'm just curious. 41. Replace the first true with an underline. and remove the one in the middle.
And just do the same for the third one.
No, done. Keep it like this.
And see if it runs.
See, one, if it compiles.
Yeah, let's
All
see.
right, that should work. Yeah, you're right. Good idea.
Nice. Code.
Nice.
Because it
Nice.
says if there are 3 neighbors, I don't care if it's dead or alive. It's going to be alive.
Yeah,
if
that's
it
true.
is 2 neighbors and is alive, it's going to be alive. So this is simplifying the code again.
By the way, if you wanted to use the value that you have there in that underscore, you could probably say like X, and then you can use X inside your
but
bracket.
we don't care about that.
Like in this case, we don't care, but that could be useful when you want to capture a variable and assert that another value, it's actually what you expect.
This is cool. I like it.
Yeah.
Now, do we even need this points is alive? But whatever, it's fine. Yeah.
It's for readability. It's more readable if you keep the variable, or you put comments, or you put variables.
It's fine. Let's leave it. I would leave it as it is for now. Not much.
Okay. Talking of superchaining, in the end, the cube there, line 37, is generating a cube.
37.
Yeah, all the line from 37 to 44 are generating cube.
Yeah.
So, would it be possible to do cube equal, let cube equal something? Basically, points to check dot iter dot whatever dot collect, the very end of it.
Well, we could do collect if we return the new point, I think, yes. And then we don't need to do insert directly.
Okay, so
yeah, because we are creating...
Actually,
I wonder, but we are using a point, then we'll need to use iterators. But probably we can use something like map or filter at that point. Something like filter map, I guess. And then collect.
So it's point to check dot
into iter, I guess.
Into is not materializing it. I don't care about materializing it. Iter is probably enough.
Correct.
Then for all of this, I only have to take the points that satisfy our rules.
Yep. So this is point, and this is going to be collect.
Yeah, let's do point that return true. We know that is wrong because point that return true. We know it is wrong because we are taking all the points. Comment that don't. Okay. So now
open semicolon there.
Except that it's not happy about item.
Sorry, I can't see because of the share screen.
Yeah, it says something about references, obviously.
Oh, you will need to map to.
To return the actual value, or
because you have like a reference of.
Okay, no, into iter was correct. So don't map, do into iter instead of iter. This time it was fine to do into iter like you did in the first time.
That should work. Yeah, because this way you have a straight reference, not
point
a reference.
Never used. Yeah, give me a second. We are
working. Okay. Do lambdas in Rust have to be single line, or can I put a code?
You can put curly braces. And...
Okay. And then move this stuff in, basically.
Yeah, move the stuff in.
And at this point in the match statement, you can just return. So you can remove the semicolon at the end, and that's it.
Filter map. Okay, we can do a filter map. No, filter is enough.
We don't need this. We just need to return true.
Yeah, we need a true or a false.
Which is what it's doing.
Yeah, can we simplify this even more? No, I think come on, simplified enough. So. He's working? He's still working?
Let's check. Sorry, I was looking to see if there's anything else. Let's see, it should be.
And due to the fact that cube is the last stuff that we return, we can remove the variable.
Yeah, we can.
Actually, yes, and you just collect.
But we needed to make sure that it works.
Yeah. And remove that, just return this expression that is...
And by the way, you can even remove line 29 entirely.
29?
No, sorry. We need line 29. We don't allocate cube anymore.
We can make this neater as well, but...
Probably we can do something even there, but okay. This one is an improvement.
Yeah, definitely nicer, shorter anyway.
So that points to check can become an expression too, probably somehow.
This thing. Yeah. Yeah, it's basically...
I think we can use a flat map there.
Yeah, the fact of having it allocated like this is that when there are overlapping points, you are just taking them in account once and not doing multiple times.
Well, we could, I suppose, reduce into something.
If we use flat map, so just a second, if we use flat map, for every points to check, we return another, let's say, list of points. The flat map should take care of making it like one list.
Yeah,
one
but
level.
what happens to duplicates?
It's a Nash set, so I think it's just going to try to do insert again and ignore them.
Okay, the important stuff is that duplicates are just processed once in line 36. Because otherwise we are adding infinite complexity to this.
Okay, so
I think in a Nash set you cannot have duplicates. It's more, I don't know if it's going to do some extra work just before it figures out that it's already there.
So this is what you're suggesting basically, right? The flat map over point and go away suggestion. We're inserting the point and also...
you were suggesting all cube iter map and then flat map. You're right. Sorry, I'm stupid.
Okay, and we return what? Because we need to return... we need to return the point, and we need to return the neighbors of the point as well, right?
The point plus all these neighbors. So
plus.
yeah, plus. I mean. Okay.
Yeah, I didn't realize the current point. Let's see if we can chain them somehow. But let's return only the neighbors for a second, just to see if this idea works. So wait, you need to return just neighbors of point.
Yeah.
In the flat map. That's
You're
what.
correct. Yeah. Sorry, my bad.
Copied the wrong.
I copied the wrong thing. It happens.
So let's see if this works as a concept. Oh, you need to do.
Iter of this. Yeah. No.
Iter.collect.
Cannot be filled. It's a reference, so I presumably... No.
Into iter?
Yeah.
Here we are trying stuff.
But an iterator, can we use an iterator from flatmap? Let's see.
But it's not a... Not implemented for hash set. From iterator, not implemented for hash set.
Sorry, let me remove the spam from the chat.
Oh.
So,
old cube into iter.
Iter?
This is a suggestion we got there.
What is complaining about?
So, sorry, Tommaso suggested old cube into iter now, but that didn't...
Yeah, but at that point is not a reference anymore.
So, hang on.
What if you say into iter.collect at the end?
No, revert that into iter and also the other into iter. Okay, go in the type definition at the beginning of the line, put a hash set of reference to point.
Okay.
Save, is happy? Is happy. Was that? Cool.
But now we also need to add the pointer here.
Yeah, we are missing the point itself. So
we can't do this in neighbors of point in the function itself.
We can't because we are using it also in the count in the function 23.
You're right. Okay, so we can probably make...
Yeah, I think we could do something with that chain, and I'm just not sure how to use it.
Or we can add a parameter, a boolean, as a second parameter of neighbor of point that is returning or not the point itself, but it's super dirty, guys. This is an array. Can't you chain array with the plus? No,
I don't know.
That is Python, right?
No, yeah. Sorry, undoing the stuff. Sorry that this is. Oh, sorry. I know a shortcut.
So neighbors of point is giving us back an array, and
Yeah.
then we do dot iter on it. Cool. Can we do an array plus one element, and then iter on top of this union? No, we can. Or we can
we
go for
add to an iter? No,
oh,
we
cool,
can't.
cool. Points to check dot. There is a way to merge two sets.
To just merge this
In
with
the line
the old.
37.
Oh, we did it in the other exercise, right?
Where?
Points to check dot.
Jesus, sorry. Dot.
Expand, update, add.
Extend.
There is union.
With contents of an iterator. So we can give it this, I suppose.
And giving the old cube.
As an iterable, but yeah. Yeah, we can.
Probably is already a set, so there isn't something between set.
Let's see. So this we know exists.
I think we can use union between sets.
But is modifying the initial one or giving you back a new one? I don't think you need iter if you do that between sets.
You're right.
No, it creates like another iterator.
You need to pass
Expected reference, okay.
Sorry, Luciano?
I think it creates like an iterator, so it's lazy. It's a lazy union. Then you need to collect and probably gives you.
Yeah.
Because we decided to make this references to points.
Okay, so we have another suggestion here. You can consume old cube there, so you can use into iter safely.
That's true.
No, the old cube is used in line 43.
Is it?
Oh yeah, we need it. Yeah.
We can't consume it.
Let's stay with the extend. Is the extend working? Comment the lines between 28 and 34, just to see if it still works like this. Then we can proceed.
It's not happy with the
type again.
Yeah, because there's references now. Because of this, which now has references to points.
Okay, let's undo the reference stuff and let's find out how to. So now probably it's old cube into iter.
No, it's happy with that. It's not happy with
this. The collect is not
this.
Okay, there we have point that is okay.
Wait, what does it want?
Make a reference there, put a reference in front of it.
Okay.
And collect now is not happy. Why?
Because it's getting a reference to the tuple.
Because the flat map is giving us a reference and not the tuple itself.
I think so.
Okay, how do we tell flat map to give us back the value and not a reference?
If I...
No, I think it's matter of the flat map. Do after the flat map a map that is materializing it. I don't know. Yeah, you forgot a dot, I think.
Yes, I did indeed.
And then you return star x. Yeah,
No,
I think there is something better than this. It's impossible.
No.
Cannot return. Now there is. Okay.
All of a sudden, I'm not disliking these fours as
much.
Yeah,
I think that first one is cool. It's cool.
They were pretty nice.
And I think the other one with the 4 is more readable also. Yeah. Okay, it's possible we are too noob to do it, but
Yeah, we're also
Somebody
coming.
wants to send us a pull request with this done.
So my suggestion is, because it's
And I also have the feeling that all of this can become just a chain of stuff in the end.
it definitely can. So I'm going to undo all of these.
Yeah. Okay.
I'll
Let's
run
go
the
to a
tests again.
Let's go to a working state and commit.
Exactly. Commit stuff that's actually working. The thing is, it is running. Yay, wonderful. Okay, let me do a commit with this stuff.
Yes, there is margin to make a chaining of stuff. Then there is the margin to chain the two variables together and having no variables, and that is completely functional programming after, more or less functional programming after that. Yeah.
This is exercise 17, is it?
17, part 1.
I know I did the introduction, but I managed to forget. Okay, exercise 17, part 1, working solution. Push. Yay, that's done. Get the PRs coming, people, because I'm sure there's a lot of stuff there that can be made nicer. Nice. What do we want to do? Do we still want to go over the PR?
But I think for today, probably.
Yeah, for today, let's close it here if we were short on time.
I definitely am, yes. Sorry.
Me too, sorry.
All right, so then I suppose we'll wrap it up here, right? So
yeah.
Thank you everybody for following along. Thank you everybody for the suggestions. They were super nice and super helpful. We should add that you can find the recording, you will be able to find the recording of this on YouTube, probably at some point tomorrow. There's a link to the YouTube channel on the Twitch, and I think on YouTube, if you're watching this on YouTube, you can find a link to the Twitch channel in the description. We stream this every Monday at 5 p.m. GMT, if I'm correct, UTC, sorry. Make sure to check the links, like go from Twitch to YouTube and YouTube to Twitch and so on. Follow us if you like what we're doing, and you want to be notified when we do something else. Please leave us comments, open PRs. There's a lot of stuff that can be improved. We're doing this to learn. The repository is on GitHub. If Luciano can share the link for the GitHub repo, that would be great. So you can go there and open PRs, open comments, do whatever you want. Well, not do whatever you want, but you get it. Everything's well accepted. We're trying to learn. Thank you very much. And we're gonna raid someone, I think, and we'll see you next time.
Yes, I am ready to raid. So 3, 2, 1,
Raid.
go. And we'll be seeing you next time. Bye-bye, everyone.
Bye.